Ahoy there, me hearties. Welcome aboard. This is Captain Cowpie and my pet bird here, Polly. Today we're going to take a look at composite functions again. Trying to find the composite. Yesterday you evaluated them, and today you're going to actually calculate the equation that makes a composite. But to get you warmed up, here's a little something to give you a little roll in your belly. The other day, I kept Polly in my cabin. When I go back to the cabin, I had left the window open by golly, and Polly had done flying away. What do you think I said? Well, at the top of my lungs, I screamed, "Polly gone!" Alright, one more talk for you. I've been getting a little forgetful lately. When I walk into my cabin and Polly looks at me, gives me this hungry look, like she hasn't eaten. And I said, "Polly, what's wrong?" And she says to me, "Polly, no meal." Alright, you scallywags. Let's get started with composite functions. You scurry dogs, tighten up that mainsail. Fix the jib. Welcome back. Alrighty, let's take a look at how we're going to find composite functions. Alrighty, if we use our model that we did yesterday, this is telling us f of g of x. Alright, that is the same thing as f g of x. So our inner function is g, and our outer function is f. Alright, now what this is telling you is this is your input. Okay, so let me fix this here. Our input is g of x. So instead of me putting a number in there, like when we did this yesterday, if I said f g of 3, then 3 was your input. It went through function g. Okay, if we did that, we'd end up with 9, 12. And then 12 would go into function f. That'd be 24, take away 1, and my output would be 23. Okay? Well, we're doing the same thing here, except now instead of having a number there, we have an x. So if we go back up here, we got g's are inner, f's are outer. So now our input is the variable x. Well, when x goes into g, what comes out is x squared plus 3. So now this becomes f of x squared plus 3. Okay, this is our new input. So g of x stands for, that's your output when it comes out of g. And that's what it looks like when it comes out of g. Now that function is going to go into f. Okay, so down here, let's see, I'll write it out. We're going to have f of x squared plus 3. So wherever I see an x, I'm going to replace it with x squared plus 3, because that's my new input. And then we simplify that, distribute. And then that is my final output. Okay, so f of g of x is equal to 2x squared plus 5. Alrighty, let's move on to the next one here. Okay, now we did this one yesterday. We did it by substituting in the number. Okay, so let's review that real quick. Okay, this right here is f g. My input is -3. So -3 goes into g, then goes through f. All right, when -3 goes into g, okay, I get g of -3, which is going to be -3 squared minus 4, that's 9, take away 4, that's equal to 5. So 5 is the output, and then that becomes the input in f, and I'd have 5 minus 2 times 5, that's 10, so that's -5. So I end up with my solution as f of g of -3 is -5. Now that was by taking the input, putting it into g, getting an output, and then taking that output and putting it into f and getting a new output. Now the other way you could do this is create the composition, then at the end plug in -3. Alright, so my second method here is I'm going to evaluate this. I'm first going to find what f of g of x is. Okay, so g's my inner, f's my outer, x is my input now. Okay, so when I evaluate this, this would be the same as g of x is the input into f of x. Alright, so x is my input, just like -3 was earlier. When an x goes into g, out comes x squared minus 4. So this would be f of x squared minus 4. And now x squared minus 4 goes into f of x. So that's going to be 5 take away 2, and my input is x squared minus 4. Okay, and I end up with negative 2x squared plus 13. Okay, that's my composite function. Now I can plug in -3. So -2, -3, x squared plus 13. And I get -5. Okay, which is what the same thing I got up here. So it's just two different ways. I would say in this particular case, it looks like this method would be a lot quicker than this method. But sometimes you need to be able to do one or the other. So here we go. So if I wanted to actually, like graph these, then I would use this method and I could graph. This is what the graph would look like of the composite. So this is where that would come in handy. Alrighty. So we'll do it one more time here. Okay, this is the same as f g of x. Okay, so it's going to go into g, then it's going to go into f. My input is x now. When x goes into g, it spits out in x plus 3. Okay, so now this becomes f of x plus 3. And now wherever there's an x here, I'm going to put in x plus 3. All right, simplify that. So we got a x plus 3 squared is x plus 3 times x plus 3. So that's x squared plus 3x plus 3x plus 9. So that's going to be x squared plus 6x plus 9. Take away 2 for a grand total of x squared plus 7. There we go. And there is your composite. Alrighty. So you have Math Excel 5, Composite Functions, Day 2. And I will see you next time.